Hi, welcome back to our video. So like what I have said, let's now have an example regarding the exact DE. So here is the steps on how to solve if we have an exact differential equation. So we have a total of 6 steps to solve, and to demonstrate this, then let's have a real example. Okay, so say we have um, equation which is in this form: 4x minus y dx plus 6y minus x dy is equal to 0. So as you can see, we are already in this form. We have m as a function of x and y. So this is our m. This is our m. This is our m as a function of x and y. So this is a function of x and y, and it is multiplied by dx. And thus we have a function of n of x and y also. So this is our n, and this is multiplied by dy is equal to 0. So we are already in this form. And first thing to us to for us to solve an exact DE is, of course, to test for exactness. And we need to prove that this differential equation here is really an exact differential equation, okay, by performing this test for exactness. Okay, so we have one test for exactness, so we need to do the partial derivative of m with respect to y, which is when we look at this is our m, and if we take the partial derivative of this m with respect to y alone, okay, partially with respect to y alone, so we will treat our x variable as constant. So we have, if we let our x as constant, then 4x, the derivative of 4x is just 0, minus the derivative of the this negative y here is, of course, negative 1. Okay, while or it is equal to negative 1. While on this part, if we take the partial derivative of n with respect to x, okay, n with respect to x, as you can see here, we take the partial derivative of n with respect to x. So my technique here, if I see this n and this is multiplied by dy, then I take the derivative of this with respect to x. Okay, if this is y n dy, then let's take its partial derivative with respect to x. Okay, as well as this, if this is m multiplied by dx, then let's take its partial derivative with respect to y. Okay, so we have to take this, and by doing this, we need to do the partial derivative, wherein we only need to treat our y as constant. So by treating y as constant, and then the derivative of y, 6y, is just 0, then the derivative of this negative x is negative 1. So by here we can see that the partial derivative of m with respect to y is equal to n with respect to x. They are both negative 1. Okay, so by doing the test for exactness, we already evaluated this given DE, which is, we can say that this given DE is an exact. Okay, then if this is exact, we can now proceed to step 2. Okay, by letting f is equal to the integral of m dx. So we have f is equal to the integral of our m dx. So this is our m dx. Then we will gonna first we'll let our is equal to the integral of our m is 4x minus y, then dx. Okay, let's integrate this part here. Okay, then if we let this, then on the step 3 we need to integrate m with respect to x. So this is our m with respect to x, keeping variable y constant. So by doing that, our integrand is some function of y plus the constant, arbitrary constant, but it is now in terms of function y. Okay, so by doing that, by integrating this part, we have, so once again we need to treat, by integrating this, we need to integrate this with respect to x, and we keep the variable y constant. Okay, constant. Okay, so by doing that, so the integral of 4x dx is 4x squared all over 2, right? And then minus, if this is constant, then the integral of constant dx is, we have x y or yx. Okay, and then plus our constant c, but here it said that the arbitrary constant is in terms of function y, so we need to plus a y. This is our arbitrary constant. Instead of by just writing c, we need to write a as a function of y. Okay, so this is our gxy here plus this term ay. Then for step 4, it says that differentiate f with respect to y naman, keeping variable x constant. So last time we integrate m with respect to x, keeping y constant, and for this fourth step we need to differentiate. Last time we integrate, for now we need to differentiate. So we need to differentiate this f, differentiate f with y with respect to y. Differentiate, we need to take the derivative of f with respect to y. So partially by keeping x constant. So we will only treat the integral, I mean the differential of f with respect to y. So what is our f? This part. So our f is this one, right? Then by taking its partial derivative with respect to y, then we keep x constant. So if this is constant, 4 divided 2, by the way, is just 2. So going back, we have 2x squared, and if this whole term here is constant, since we will keep the variable x constant, then the partial derivative of this part is just 0, because the derivative of constant is 0. Then minus the derivative of constant times y. So we have the negative x, right? This is constant and we will only treat y. So the derivative of x, negative xy, is just negative x. Then the derivative of this a y is, a as a function of y is a prime of y. So let's have this notation, or denotation, by saying that the derivative is in terms of prime. So we have a prime y. Or let's simplify this, we have negative x plus a prime of y. Okay, so we are already in this form. The derivative of g, this is our g, derivative of g with respect to y, and then this part here, the derivative of ay is a prime y. Okay,